Welcome back, learners. Now to jump to our first concept, where we'll be looking at the conductors of electricity. To begin with that as our main idea, as our main subheading being the conductors of electricity, we need to know that some materials such as metals, they are good conductors of electricity, whereas non-metals except for carbon in the form of graphite. So carbon in the form of graphite is those ones are insulators or non-conductors of electricity. Remember, we're saying that non-metals are insulators except for carbon. However, that carbon must be in a form of graphite for it to be able to conduct the electricity. Then all matter is made up of atoms, as we know that all matter is made up of atoms, and an atom consists of positive nucleus surrounded by negative electrons. So in the nucleus, we find protons, which are positively charged, and the neutrons, which do not have a charge, which is why we're saying that the nucleus is a positive nucleus, because we have positive substances there, or positive substances there, and then the other ones, they do not have a charge. So the overall charge of a nucleus is going to be positive. However, around the nucleus, we are finding the negative electrons, which are forming an electron cloud around the nucleus. And then they are surrounded by negative electrons that are moving in energy levels. So we have different energy levels that each of these electrons are occupying. So these energy levels are like layers of electrons. So as we have said, we have different energy levels that each of these electrons are going to be occupying. So we can take those energy levels as layers of electrons, that on each energy level we find electrons. When we go to the next one, we'll still find electrons. So basically, we're going from layer to layer. On each layer, we are still finding electrons. Then in metals, the electrons in the outer energy level of an atom become free. So because we are saying that we are going to take those energy levels as the layers, that means on the outer layer, we have electrons in metals specifically. We have electrons that are going to be free or delocalized. So those electrons that you find on the outer layer of an atom, they are called, or they are said to be delocalized, or we can say that they are free. And the remaining part of the atom, which is the metal ion, become positively charged. So that means the electron, once an atom loses an electron, it becomes more positive, because at the beginning, initially, there's an equal number of protons and electrons. So once now the atom loses one electron, there's going to be more protons than electrons. And remember, protons are positively charged. So if an electron now becomes free, then that means whatever that is remaining is going to be an ion. But then because this was a metal, as we have said, it is going to be a metal ion. And that metal ion is going to be positively charged because that atom has lost an electron. So these outer electrons move between the positive ions of the metal atoms. So those electrons that you find on the outer layer, they are going to be moving between positive atoms of an ion. Then a metal, therefore, consists of an arrangement of positive metal ions and delocalized electrons. Now, as we can see on this picture here, we have our free electrons. Now, the free electrons are the ones that are going to take part in any chemical bond, and as it stands like this, the electrons, they are moving in all random directions. However, the moment you start connecting a wire in those two, or connecting a battery or a cell in that particular metal, then the electrons will start moving in the same direction, going towards the positive terminal. In addition to that, if a metal, or rather a conducting wire, is connected to a battery, as we have said, that metal that has the delocalized electrons, the electrons that are free to move around wherever and however they want, as we can see, all of these blue dots, they denote our free electrons, and you can see the arrows, the arrowheads are showing different directions throughout this entire metal. So if a metal or conducting wire is connected to a battery, then the electrons, they're going to move through the wire in the same direction. Once we are connecting a battery on this wire, the electrons will move in the same direction, as we can see that the arrowheads are now pointing towards the same direction. So they're going to move in the same direction between the metal ions. That is, now they're going to be moving towards the positive terminal of the battery. Once you connect a battery in that conducting wire, then those electrons that are free to move around, those delocalized electrons, will now be moving towards the positive terminal. And when that happens, we are saying that that generates electric current. So as those electrons are moving towards the positive terminal, away from the negative terminal, that generates our electric current. So what we're then saying is, in addition to that, is in all conductors, there are collisions. Because these electrons are moving haphazardly, they're just moving randomly throughout this entire metal, at some point they're going to collide. So the collisions are going to be between electrons and the metal ions that cause a degree of resistance against the flow of electric current. So that collision between the electrons, or that collision between the electrons and the metal ion, is going to now cause the resistance against the flow of the electric current. However, in insulators or non-conductors, the outer electrons are bound tightly to the atom. Remember, in the metals, the outer electrons are free to move around. They are called delocalized electrons. They are free to move around wherever and however they want. However, in insulators, those electrons that you find on the outer layer, they are bound tightly to the atom nuclei and cannot move freely. So they are bound to the atom nuclei, and they cannot be able to move freely as compared to the electrons that you find in metal, or that we can refer to them as our delocalized electrons. Now, because of that, because those electrons are not able to move around however and wherever they want, there is not going to be any current that is going to be generated today, which is why we're saying that insulators, they are bad conductors of electricity. It is because of those electrons that are tightly bound to the atom nuclei and they are not able to move freely. And because of that, there is no electric current if an insulator is connected to a battery. So because we said in metals, once we connect that metal to a battery, there's going to be the movement of electrons towards the positive terminal. And because of that, we are generating the electric current. Now, in this case, because now those atoms, or those electrons, are tightly bound, they are not able to move anywhere, so therefore there won't be any current that is going to be generated. And whenever we are connecting our battery to that particular substance, being an insulator, there's not going to be any movement of the electrons from the negative terminal to the positive terminal. So before moving on to the next concept, we're just going to go for a quick short break, and I will see you just after this.